So let's look at the circuit diagram. So what I've done in the circuit diagram is I've put nodes in specific colors. So a node is a part of the circuit where you have two different components making connection. So in this particular case, I'm highlighting the yellow node. What a node is going to translate to on your protoboard is it's going to translate to a specific column. So what I'm going to do when I build the circuit is I'm going to place a component and I'm going to assign in this box the number of the column that I've plugged it into. So we're going to start off by first plugging in the transistor to the board, because the transistor is the one that's the most complicated in terms of getting the pin configurations correct. So the idea is just that I want to build this circuit. I want to do it in a systematic way. So the very first step is I identify all the connection points. So like this first connection point, I need to plug in the LED. I also need to plug in the positive side of my 9-volt battery. This yellow box, I need to plug in the short leg of the LED, and I need to plug in the 470 ohm resistor. The green box, I need to plug in the 470 ohm other end of the resistor, and I need to plug in the collector of the transistor. And so from each one of these points, you can see that I have multiple things plugged in together, and so that's going to correspond to a specific column on your board. I want to start off with the transistor. So the transistor that we're going to use, it has this particular pin layout. So you can start taking out the parts. Oops. Dropped a bunch of wires. So the bag that you want is the bag that has the paper and has the circuits. So don't take out all the resistors just yet. The part that I want you to take out is just one out of the 4 transistors that are there. So pull out a single transistor like this one and just start looking at it and notice that there's one side that's flat and the other side that's rounded. And if you look at the flat side, let me do dual screen. So let me do this and that and shrink. Okay, so you should be able to see both. I'm going to take my motor project out. Oh, and I forgot to unplug the battery. So don't do what I did. Make sure you unplug the battery when you're not using it. So take out the battery, set this aside. There is enough space to build this project without disassembling the motor, but I'm just going to disassemble the motor so that we have plenty of working space. So what I have is my transistor. And again, there's a flat side and a rounded side. So when viewed from the top, right now I have my flat side pointing downwards. So my higher contrast background. So I have the flat side pointing downwards. And I have my breadboard oriented with 1A in the bottom left corner. So we're first going to plug in this transistor. So notice that on the flat side, from left to right, it goes collector is the first pin on the left, base is the middle, emitter is on the right. And the transistor diagram, the collector is this top piece, and the emitter is the bottom piece that has the arrow, and then the base is in the middle. There are other transistors which, because of the technology, they actually switch the emitter and the collector. So the emitter is on the left and the collector is on the right for other types of transistors. And we had some projects where we had both types of transistors and just confused the students. So we decided we're going to get all of the identical transistors for all of the projects that we do. So now that you know which side is the collector, which side is the base, which side is the emitter, we're going to plug this into our circuit. So we want to build this as the circuit. And so I need to pick a column to plug in the collector. And then based on that, I'm going to use the adjacent columns for the base and for the emitter. So I'm just going to arbitrarily pick column, let's say 20 for the collector. So the leftmost pin is going into column 20, and I'm picking row F just for convenience. So right now I have the collector here, that's this part here. This is in 20. And I'm going to just work with the upper half of the board. I'm not going to use the bottom half. So I'm going to use rows F through I. So I have my collector in 20 in the upper half. The adjacent pin is the base. So the base is in 21 in the upper half. And then the emitter is in 22 in the upper half. Okay, so has everyone gotten that plugged in? And make sure that the flat end is pointing down so that you have the collector in 20, the base in 21, and the emitter in 22. Okay, so the next part of the circuit that I'm going to add is I'm going to add this 470 ohm resistor. So in your paper tape out, which Lucas and several of the other assistants helped to tape out, pull out one out of the two 470 ohm resistors. So one end of the resistor needs to connect to the collector. So one end of the resistor is going to go into column 20. I'm going to arbitrarily pick that the other end of the resistor, I'm going to put this in column 25. So my components, I'm going to space roughly 5 columns apart. So I'm picking row H. It doesn't matter exactly which row I pick, but for convenience, I'm picking row H. And one end of the 470 is in 20. The other end is in 25. Okay, and then next I'm going to take the LED. You can either use the LED from the previous example when we did design of experiment, or you can pull one of these LEDs. I'm just going to pick the green one. You can pick the yellow, you can pick the red, you can pick the clear ones from the previous activity, it doesn't matter. And so remember, the LED acronym is positive, or PAL. LED is our PAL. The positive end, which is this end here, is the anode, which is the longer leg. So I want the shorter leg to plug into 25. And based on just the size of the LED, I'm going to use 25F, and the other end I'm going to put into 26F because it's nice and convenient. They're already spaced by 1. So I have the long leg in 26 and the short leg in 25. So that means my red box here is 26. And then I need to put in my 1 kilo ohm resistor. So you can pull out one of the 1 kilo ohm resistors. And one end of it is going to go into 21, and the other end of it can go somewhere else. I'm just going to pick 15. And just for convenience, I'm going to use row J. So I'm going from 21 to 15 with this resistor. So this other end is 15. So the last part of my circuit, I need to apply the battery sources. So I need my 9-volt battery clip. And I'm going to have the red end here, which is in 26. So just find a specific spot in 26. Doesn't matter exactly. Plug that in there. I picked J, 26. And then the other end, the black end, is going to be ground. So the ground is down here. So that's in column 22. So I'm again going to pick J for convenience. So that's my 9-volt battery. And you can try to plug it in before you connect the 3 volts to see what happens. So remove the battery protector from the 9-volt battery. I like to save this because this can use to store the battery. Afterwards, I can plug it back and store the battery in a drawer. And so I'm going to plug in my 9-volt signal. It looks like my wires have both popped out, so I need to do that again. So the red was in 26J. And the black was in 22J. All right, so I see that there's no, the signal hasn't lit up. So now what I want to do, I want to connect my 3-volt battery. So I take my 2 AA battery clip, and one end of it is going in column 15. So I put the batteries in the battery clip. The positive end is going in column 15. And I'm just going to pick 15F. And the negative end is going to 22, where the other black wire is. It's 22. I don't know if that's better or not. So I've made a type 3 error. I've plugged things into 23 instead of 22. So these both should be in 22, not 23. Having trouble with the 9-volt clip. Okay, so now I can see if I disconnect my 3-volt signal, the LED is off, and when I apply my 3-volt signal, I'm controlling the 9 volts that's flowing the current through the LED. So the transistor circuit, this lights up when I have the 3-volt signal and the transistor's on. And when I disconnect the 3-volt signal, it turns off. How are people doing on building? If you have questions, ask them in the chat. Or unmute and ask them directly. Maybe a thumbs up if you've built the circuit successfully. All right, we got about 5, 6, 7. Okay. So are there questions? Like the people who haven't finished yet, I guess, what are your questions? All right, so I guess there's no questions. So some of the other things you can try. So the brightness of this LED, so kind of keep in mind how bright it is. Instead of applying the 3-volt signal, we can also try applying a 1.5-volt signal, but we only do one at a time. So what I'm going to do is I'm going to disconnect. So I'm going to break the circuit with the 3-volt signal. So I've taken off the positive side of the 3-volt. I can also take off the negative side. It doesn't matter anymore. A single disconnect would be adequate. I'm going to now try my single AA battery instead of the 3-volt AA battery. So I'm plugging in the 3 volts, the positive to 15, and the negative to 22, where the other black wire is.
What would happen if you put in like 4.5 volts, like with both of them?
Say it loudly. What happens if you put?
Like 4.5 volts, like with both the two batteries and the one battery.
Yeah, so if you use the 2 AA plus the 1 AA, you have to be careful how you do them. If you put them in series, then that'll give you 4.5 volts, and that's safe, and it'll light up to the same brightness as this currently is. If you put them in parallel, you're going to burn something out because one of them is trying to set the voltage to 3 volts, the other is trying to set it to 1.5. I think most likely what's going to happen is that it's going to start to try to charge that 1.5 volt battery because you have this excess voltage, and that battery will start to heat up and probably get damaged. So you can see the brightness level is about the same as it was before. So I get the same amount of current flowing through the LED. It doesn't matter that I've only put 1.5 volts instead of 3. As long as I'm above that 0.8 necessary to turn it on, then I'll get the same amount of current flowing. And the current flow only really depends on the 470 ohm resistor and the LED that's in place. So in this particular case, the LED, let's say it drops, it needs 2 volts. It might be 1.9, depending on the color of the light. But let's just say it's 2 volts. So there are 7 volts left to drop across this 470 ohm resistor. So the amount of current that flows will be 7 volts divided by 470 ohms. I'm going to round that to 500 ohms and say 7 volts divided by half a kilo ohm. That's going to give me 14 milliamps of current. And so 14 milliamps of current is a safe level for the LED to operate. If I go above 20 milliamps, I'll probably blow out my LED. So some of the other things that you can look at, go ahead, question.
What happens if you change the 9-volt battery to a lower voltage?
Yeah, so that's a very good question. That's what I was about to ask. Maybe I should ask the others. So the other campers, what do you think will happen if I change the 9 volt to 3 volts?
Will it just be dimmer?
Yeah, it'll be dimmer. So with 3 volts instead of 9, I only have 1/3. Well, I dropped 2 volts across the LED, so I only have 1 volt left. So it'll be 1/7 as bright as when I have the 9 volts. Where were the 2 resistors supposed to go? So the 1 kilo ohm resistor, I put between 21. So 1 kilo ohm I put between 21. It looks like, oops, it's like I've accidentally bumped something. 21 and 15 in row J. And the 470 ohms, I'm going between 20 and 25. And it looks like I'm using row H. I think I've accidentally broken, oh yeah. The 9 volt battery negative wire keeps coming out. Okay, it stays. Yeah. All right, so we finished slightly earlier than expected. So now I'm curious whether people want to build this circuit. I'm not sure it can be built in 20 minutes, but we can attempt it if people are interested. Yep, go for it. All right, so disconnect your batteries from the battery clip. So unplug everything. And then, yeah, pull those out, pull these out. Okay, so this is a flashing LED circuit. The challenge in building this circuit is that the wires are going to cross, and you have to be very careful how you lay this out. So the first step is we want to label the parts of our circuit diagram. And this upward arrow, this is going to be where we apply the positive part of the battery. And the batteries that we're using for this one is 9 volts. Okay. So that'll be sort of the last step, is to apply the power. Generally, when you build circuits, you want to put all your components down, then apply the voltage, see that it works or doesn't work, and then continue on. So I'm going to start this one completely over. I have to keep track of which resistor was which. So this one here, this is the 1 kilo ohm. So I'm going to take out the 1 kilo ohm. I'm going to put it back in my set of parts, just so that I don't mistake it for the 470. So I put the 1 kilo ohm back, and then I'm going to take the 470. I'm going to put the 470 back as well. Can't get it back. Okay, I'm going to set aside the 470. All right, so the trick with this particular circuit, as I mentioned, you have crossing wires. The way that they've laid out the transistors, there's also jumper wires to make some of these connections. So I would say let's place the two transistors first. So let's do this one and this one first. So this one on the right side, I'm going to roughly use the same pins that they have here. It looks like it's 18, 19, and 20. So the one on the right side, the collector, which is on the left, that's an 18. So here, this was 18, this is 19, and this is 20. And the other thing to keep track of, this is using the rows F through J. So I call that the upper, because I usually hold my board horizontally. So 18, 19, and 20 upper. So let me pull out the LED. Go 18, 19, 20 upper. And I'm going to use row H. That's that one. Oops. Let's do flash. Okay. Now I need a second transistor. So the reason we gave you 4 is sometimes if you connect these things backwards, it blows out the transistor. So that prevents you from doing some of these activities. Okay, so now again, we're going to have it face the same way. And I'm going to use 18, 19, 20 again on the lower half. And this time I'm going to use row C. So this one here is 18, 19, and these are both lower half. And I've plugged in here 20 lower. So I need a jumper wire to go from 20 lower to 20 upper. Fortunately, I spilled my wires. So I'm going to pick a yellow one because that looks about the right size. And I want to go from 20 lower to 20 upper. So let me move that. Yeah, it's not ideal, but. So I'm going to use E and F. And then I just flatten this out down to be out of the way. Okay, so I've connected, this is 20 lower. And I've connected, so this part was 20 lower rather, and I've connected 20 lower to 20 upper. So I've made this connection, this connection, this connection, this connection. So the transistor is in place. Now I'm going to do one of the capacitors. So I need to go from 19L to 18U. So 19L to 18U. So I am going to pick 19G and 18D. Which may or may not be a good choice. And then I'm going to push this capacitor out of the way. And then the other one, so I went from 19, or so let me see which one I just did. I went from 19 upper. So I actually did this capacitor. So I did 19 upper to 18 lower. So now the second capacitor is going to go from 19 lower to 18 upper. So the reason I picked those particular rows is I wanted to leave space for this other capacitor. So I'm going to go from 19 lower, so 19E to 18F. So I've managed to cross these two capacitors without them touching each other. So one is standing up, the other one is not. Yeah, so make sure no metal touches components because otherwise you're going to short circuit.
Confused. Wait, where does the capacitors go?
So they're going to crisscross. So the first capacitor I went from 18D to 19G. And the other one.
Wait, I already have something in 18D. I don't.
So there should be one other thing in 18. Currently I have 18H for the transistor.
Yeah. I have 118H. We have two transistors in, and I have 18. I have 18H for one transistor and 18D for the other one.
Oh, the other one needs to go on the other half of the board. So if you put both transistors on the upper half, then they're going
They're
to.
not both on the upper half.
Yeah, you want one on the upper half, one on the lower half.
Yeah, that's how they are.
Yeah, so like that. So the one on the upper half is in row H, and the one on the bottom can be in row C.
And then the comparator goes on 18D and what?
So the capacitor, I did 18D and 19G. And the other capacitor, I did 19E and 18F.
Wait, the second one is 19D and 18F?
19E, 18F. Do other people have questions?
What's the purpose for them like crossing each other?
Oh, so we want to be able to have the left end circuit drive the right end's transistor. So when this left capacitor charges up, the charging up it has to do with the current that flows through the light. So the way that the circuit works, the current will flow through this LED and the LED will be lit up, and then it'll store charge in this capacitor. And then once the charge in the capacitor is great enough to block the flow of current, then it's going to change the way that the second transistor works, and it'll cause this LED to start flowing current, and so it'll alternate back and forth.
Are they supposed to be crossing on both sides of the breadboard? Or just one? Because mine is.
So you can see in this diagram, one of the capacitors goes like this, and the other one goes like this. So the way I've laid it out, it's not as bad because I've pushed this bottom one, I've pushed it out of the way. But if I had it standing up, they would just make an X. So I've pushed one of them flat so that it doesn't get in the way of the other one.
Yeah, but like I have an X on the A, B, C, D, E side, but not an X on the F, G, H, I, J.
Yeah, so you should have it cross either on one side or in the middle.
Okay.
Okay, so we've gotten this transistor, we've gotten this transistor, we've gotten this capacitor, we've gotten this capacitor. Okay, so next what we need to do is we need to put in some of these resistors and LEDs. So let's build on the lower half. We need a 470 ohm resistor, the one that I just set aside. And we're gonna go from the lower half, 18L. So I'm going to pick, I guess it doesn't matter. I am going to pick row A and go from 18 to, let's just say, 13. So 18A to 13A with the 470 ohm. And we may as well do the upper half as well. So for the 470 on the other side, oops, we're going to go from 18. So by symmetry, I'll go from 18J to 15J. Or sorry, to 13J, 18J to 13J.
Is that 470 ohm too?
Yeah, so this is 470 ohms for both of these. So what I did here was I plugged, why is this not getting right drawing? I plugged this into 13. So for the 470, I went from 18A to 13A. So this is on the lower half of the drawing. And then on the upper half, I went from 18J. So like this side is 18J, and then this side is 13J. So that's my 13 upper. And then now I can add my two LEDs. So I'm going to pick yellow and red. Actually, the red is harder to untape. I'm just going to do yellow and green. So on the left side, I'm going to use my green. So I'm going from 13L, and I'm using the short side of the LED in the in column 13, and the right side is going to go into 12. So I'm going to go in, let's just say, C. So I'm going 13C to 12C. It looks like my pins are off by one. So I said 13C to 12C.
Which one's the short side and which was the long side?
For the LED, the short side is the side with the bar. The long side is the side.
Like where does the short one go? Where does the long one go?
Oh, so I put the short one on 13C and the long one on 12C. And then with my second LED, the one that's on the right side, I need to go from 13, let's say H to 12H.
And the long one's on 12H.
And the long leg is the one that's in 12. The short leg is in 13. And then I need another jumper wire. So I need to connect the top edges. So right now, this end is on 12 lower. This end is on 12 upper. So I want both of those to connect to this red dot, which is kind of off the screen. So I'll move this, but then I need to move back down because all these numbers. So I need to somehow connect my positive voltage. Oops. Okay, so the left edge, I had 12 lower. The right edge, I have 12 upper. I need both of those to connect to each other. So I'm going to use a yellow jumper wire. And I'm just going to pick E and F in column 12 for the jumper wire. And I push that out of the way. So that makes this connection across here from this side to this side. And then next I do the 100 kilo ohm. So I need 200 kilo ohm resistors. And one of them is going from 19 to 12. So let me see, 19 to 12 on the lower half. So I am going to pick, there's not a lot of space. I'm going to pick 19B and 12. So I don't want my wires to touch. So 19B, and I'm going to do 12D. Is that good? Actually, I'm going to do 12B. So 19B and 12B, I think is better.
Wait, which one is this?
This is the 100 kilo ohm resistor. So I'm doing, my mouse go. I'm doing this from 19B to 12B. I'm doing this component here, 19B to 12B. Yeah, just to make sure the resistor doesn't touch, my other resistor I'm going to fold flat so it's completely out of the way. And then now this other 100 kilo ohm, I need to go from 19 to 12 in the upper half of the board. So by symmetry, I'm going to push this other resistor flat. And I'm going to go with 19I. I need to move my transistor a little bit. 19I to 12I. All right, so now the last step. So I've done these resistors. These are all done. I've done the LEDs. These are all done. The transistors and the capacitors are done. Now I need to apply the 9 volt from 12 to 20. So it doesn't matter which side, upper or lower. I'm going to just go with the lower. So I'm going to go from positive on 12A and negative on 20A. I'm crossing my fingers that I haven't messed up, so I'm going to plug in my battery and check. Oops. And it works.
Where does the negative go?
The negative goes to 20A, and the positive was 12A.